Okay, welcome back Year 12s to this video. I'm going to run through the recursion and financial modelling questions that were in your exam 2 trial. I have put workings already on the screen, but I'm going to talk through those workings. But again, you don't need to go through every single question. Obviously, if you've known how to do it, please just skip ahead to the questions that you do need some help on. So with this first one here, we've got someone playing a guitar, and we've got a cost price of that guitar, so the 3264. We're also told that the value of the guitar is going to go down, so it's depreciating over time, but it's depreciated by a fixed amount for each concert. So when I see that, I'm looking at it being flat rate depreciation or unit cost depreciation, depending on whether it's a time or a use. Now, if you have a look here, it's saying that that it's a fixed amount for each concert. So then I know straight away that it's a unit cost. It's got here 25 concerts and the value of the guitar. So it's giving us information on how fast or how much it's losing each concert, or enough information to find that at least. So the value of the guitar after 25 concerts, a nice straightforward question to start off with. We've got its original value, 3264. We've got that it's losing, or it's going to be decreased by 200. And so we're just subtracting 200 to get our answer for this one. The next one, though, is asking for a calculation to show how we can get this $8 per concert. So what we can do here is we can look at how much has it lost. So how much is the depreciation, how much is D, and we can look at how many concerts, and we do that division so we can get a per concert depreciation. So this was how many concerts, and of course when we do that we can be satisfied then that we know our answer is correct because we got 8 as we anticipated. We were given that part already. So 200 divided by 25 is what you needed for that mark. The next one here, we were given basically a template to get the rule for the nth term, so GN, and we want to put the appropriate numbers in. So what we know is that generally for rule for the nth term, we're looking at the original term subtracting n times d, and that's really the structure that we're working with here. You've got the subtraction already, the minus, and we've already got n as well. So in here we want V0, which was 3264, and in here we want how much is it losing every concert. Of course we call that d, the depreciation. In part D, you're actually, you can use that particular rule if you wish, and you'll see I've done that here to get an answer. First of all, we want to know how many concerts it's going to take before the value drops below the 2,500. So that means that our GN value is 2,500. And you'll notice that I've substituted that in for GN. I've put it in its place. And then I've written the rest of my rule there. And then I have used, for this bit, I used solve. Or you can solve by hand if you find that faster. I used solve and I got 95.5. So what that means is it's halfway through that 96th, in fact. He's done 95 concerts. It's halfway through the very next one that his guitar is going to it's going to get to 2,500. So it's not till it's after the completion of that concert that it's dropped below 2,500. So it is important that we round that value up. And so it is after 96 concerts. Now, you wouldn't have wanted to use recursion in this case because it wouldn't have been a fast way to get to your answer. You would have been pressing enter on your calculator many times. So here, using that rule for the nth term is definitely your best approach. On to the next one now, question 7. We've got someone playing drums in the band and a new drum kit is required. Now, it is all about saving, and the amount saved so far is 2,500. We have a recurrence relation as well, and we've got compound interest because I can see this here, it says compounding monthly. I can also see in here that it's compound interest as well because it's in the structure of R times TN. Okay, so we want the total interest earned in the first 5 months. So your first step here is to actually work out how much does this investment have after 5 months. So what is T5? Now you could have used your sequence here, popped it into your calculator and gone enter, 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 enter until you get to the 5th term. But of course, I'm always looking to do things a little quicker or more efficient, and you'll see what I've done here is I've just created a rule for the nth term. So I've used the 1.0036, our R value. I've raised it to a power of 5 since I want T5, and then multiplied by that original amount, which was 2,500. So this is the amount here, the 2,545, that Tisha has after 5 months. We didn't want that though. We wanted total interest. So total interest in this case will be looking at the difference between what she's got now and what she started with, because this investment has only gone up by interest alone. She was not adding to that investment. That would be different. It would be a different calculation. It's only been growing based on interest. So if we look at the difference between them, she's got an extra $45.33 rounded to the nearest cent. Moving on to the next one, it's getting a little bit more complex now. She has invested the $2,500 in a different account. Now we have a new interest rate, it's 4.08, but we can also see that it's compounding monthly. So we want to be careful there with our annual interest rate, make sure we do that division by 12. She's also going to make a payment of $150 into the account, so we have to make sure we incorporate that, because as you can see, we are creating a recurrence relation in Part B. V0, that's our starting term of this investment. Of course, it's 2,500. To get the next term, we're going to have to multiply by R, but then we're going to add on the 150 is what she's adding. Now, where do we get this R from? I've just put a little calculation here. We know that R is 1 plus your percentage per annum over 100, but we need to make sure we divide it by 12, and that is where most of the errors with these situations, these sorts of questions, they occur when we forget that that annual rate is obviously for the whole year, but this is compounding 12 times a year, so we have to divide that rate first. So when you do the 1 plus 4.08 on 12 on 100, you should get 1.0034. Now, in this next question, you'll see she wants to have a balance of 4,500 after 12 months, and we want to know what interest rate she'd require. Now, we can't then use our recurrence relation. Our recurrence relation has got an interest rate of 4.08, but this is saying, well, actually, we need a different rate for this to be possible. So you'll notice here, I've gone straight to using the finance solver. If I'm not told to use this recurrence relation, and I can't use it in this case anyway, the financial solver is my next tool. So we've got 12 months in this investment. We don't know I, so I've put a question mark for now. PV is what she starts with, which is 2,500. Notice we need to put a negative because this is an investment. Tisha is giving this money to the bank for the 12 months. PMT is also negative because Tisha is adding to this investment. So that 150 is going to the bank in addition to this amount every single month. Future value is what we want, and we're told we want a balance of 4,500. So you'll notice that is in our FV value, but you'll also notice that it is positive because that will be Tisha's money that goes to her at the end of the 12 months. And finally, it's monthly, so we put our PPY, CPY is 12. Once we do that, we then go to I and we press enter and we get our rate. And you'll notice we wanted 2 decimal places, so we round it off. So 5.87% is the answer. Now it is only worth 1 mark, so this part here, you're not getting any marks for that, but I needed to show you what would have gone into your calculator. It is a good idea to have it there as well, because if you've got time at the end to check your exam, you can then see what you've entered into your calculator, and you might be able to see perhaps if there's an error, say if you dropped a negative. You can't do that if it's just been left in your calculator and then erased when you've changed to a different question. Okay, so on to the last couple now. We've got, obviously they're getting a little bit wordier now. They're getting a little bit more challenging. So we've got an annuity in this case. So $50,000 is being given to the band. Now, that's providing them a payment. So they're actually withdrawing from this money, but the money is earning interest. So it's earning 3.12% per annum. It is compounding monthly, so we keep that in mind too. That's important. And this piece of information, 6 months in, the band has this amount remaining. Now, we are asked the value of the monthly payment. You'll notice we weren't told what that was in this information. So I am going to use the solver here. It makes the most sense to do that. And I start entering the information that I have. I know after 6 months that I've got this value in the annuity. So I can put N is 6, and I can also put an FV of 32667.68. Now that's also positive because that's money that the band still has. It's still their money that they could withdraw after 6 months. However, some of these other ones are going to be negative. So if we have a look over here, for example, how much was given to them to start off with? Well, $50,000 was given to the band, but then that money was invested. So it went to the bank. So it needs to be negative. The rate is straightforward, 3.12, and as is the PPY, CPY, that is 12. You'll then scroll to your PMT and you'll press enter, and you'll notice that rounding, you get lots of zeros, you get 3,000.000, etc. So the value in dollars will be 3,000. Okay, this last one is a little bit trickier. It is a two-part solver. We know that we need to expect two-part solver questions. They are, I guess, the challenge within this topic, and here we have one. So after 6 months, the band decided they need more time and they want to extend that annuity. And to do that, they're going to work for 3 months without taking any money out. After that, they're going to take some money out, $3,800, and they're only going to do that for as long as they can. And we want to know how long is that? How long in total is this going to last, this annuity? So it's in two parts because part one, we need to know how much money is in the annuity after these 3 months that the band is not withdrawing money. So N will be 3, it's 3 months. The I value is the same as before. Now PV is why we're starting after those 6 months. So we're not starting from the very beginning. We don't need to because we know this information up here. After 6 months, the band has got 32667.68 remaining. So I'm going to start from that point because that is the point when they stop withdrawing money. So at the beginning of this time period, we've got this PV. Make sure it's negative because it's at the start of this investment. PMT we're changing to 0 because they're not withdrawing money. All the other stuff was the same. So the PPY, CPY stayed the same. I then solved FV and found what that was. And so now what I know is after this initial 6 months, an additional 3 months, so 9 months have passed altogether, they have 32923.15, etc. in the annuity. Now what we need to do for this last calculation is make sure we move that FV into PV. Now you can use Control C, copy, pop it into PV, Control V for paste, and change the sign. Make sure it's a negative because we're looking at the start of this final period. It's still an investment, and with an investment, your PV should be negative. I has stayed the same. PPY, CPY has stayed the same. Payment will change to $3,800. It is positive because the band is withdrawing it. It's coming to them. The other thing that's changed is FV because we want to know how many payments, so N, how many payments until there's nothing left in the annuity. So that's why I put a 0 there for FV. I then press enter on N and it's given me 8.77. So that means 8 full payments and 1 smaller one because we've got 0.77 blah, 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 blah of a payment. And you'll notice it does mention that here. There's one more one that's going to be smaller than the others. So we're still considering that as a payment, but it is a smaller one. They've told us that. So altogether, we want to know the total months. We had the 6 months to begin with. We had the 3 months when no payments were being taken out, and we have 9 payments in this last portion, 8 full ones and 1 smaller one. So altogether, we have 18 months worth of payments, or some of them weren't payments, of course, but 18 months from the beginning of this situation to the end when there's no money remaining. Do make sure that you show your workings, because as you can see, this is worth 2 marks. So you shouldn't have just an answer there, particularly if your answer is incorrect. You then don't give yourself any opportunity to pick up perhaps a method mark. So do use the space they've given you, many lines here, and demonstrate what you're putting into your solver. I'll stop there. Thank you for watching this video.